All right. I'd like to start off by thanking all of you for taking the time to attend our presentation this afternoon. Hello, my name is Lance Zurich, and today we're going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting a project-based class, and that's where students will be required to design and build a series of original prototypes based upon their own research and their own activities. And each of these sets will include standards-focused curriculum, which was created especially for Studica by noted STEM expert and educator, Tom White. So today we're going to start off where so many technology-focused presentations for education seem to start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics, what these people are essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market that they will graduate into. Now, in the employment market that once greeted our grandparents or even our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and rapid advances in all aspects of technology. Now, in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. Now, this is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Every new advantage we enjoy, and this can include the tablets and the smartphones that we all use daily, was created because of individuals who helped to make those advances. Countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but to be part of the next wave of advancements we rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, what we're going to do instead is we're going to move right along to the main topic, which is, of course, mechatronics. Mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to and all skill sets that are highly prized in today's technology-focused job market. But just how prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they need to start developing these habits and the career focus as early on as possible, in high school, if not even in middle school. The dilemma for educators, whether in the classroom or the homeschool setting, is finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process, and not just memorizing obscure facts or ideas to take a few tests and then promptly forget them. No, to best help students to be successful and to really encourage them to consider pursuing further education in subject matters such as this, educators need to be able to present the material in a way that makes it relevant, which means answering the eternal student question, why do we need to know this? And it also needs to be engaging in a way that holds students' attention better than rote textbooks and lecture presentations. And it has to be something that has visible real-world applications in which the students can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one of which is designed as an introduction to the world of mechatronics, and one which is intended to be essentially a standalone class dedicated to the subject. These sets were created to provide all the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which was created especially for Studica by noted educator and STEM expert Tom White. This curriculum comes as a downloadable PDF, which is available for free with the purchase of each set in whatever quantity you need. Now, this curriculum is designed to align to the most widely accepted academic standards that are currently in place in the United States. The curriculum is also designed for offering a project-based learning experience, and this means that solving the problems that arise in each unit will require the students to be actively involved in the research, the design, the trial and error experimentation and activities, and the building of actual working prototypes that will provide the required answers. And students won't do this alone. They'll be asked to work in small groups or teams of 4 students each. This will help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And by, of course, soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials each group will need to enable it to address all of the design projects presented throughout the course of this curriculum. The curriculum is designed to enable teachers of all types of backgrounds, even teachers from non-science or technology-focused disciplines, to have the information they need at hand to properly prepare them for conducting the activities and to increase their comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for both student learning and for the teachers as well. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system they will use to address the projects presented in each unit. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario, where students must work together in small teams, again, teams of 4 students per group, and they have to work together to create a solution to the problem that's presented to them. Now, the project units each contain embedded academics, and at the end of each unit, the students will be required to make a formal presentation of their prototype that they've created to address these particular units' real-world style scenario. And they also have to explain the reasoning behind why they constructed their prototype the way they did. There's also a technical literacy task driven by each of these projects. As students work to address each project, they will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Now, again, as required by each project, students will be asked to create original prototypes and any programming that's required for any of the programming solutions, and they also have to maintain detailed documentation during the entire process. Now, as I've already mentioned a few times during the presentation, the curriculum that accompanies each of these Mechatronics program sets was created especially for Studica by a man named Tom White. Now, Tom, as you see on the screen over here, Tom's a noted educator who's been involved in teaching STEM and technology since the 1970s, designing programs for educational institutions and for industry use. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other like topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. And this includes the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. So when students ask, why do we need to know this? It's usually because the subject matter that they're being presented with might be coming across as either too abstract to or just not relevant to ever be useful in their lives. Instead, with this project-based approach that we use, students get to see firsthand why these things are necessary and why they're useful. The concept of working in the small groups to solve the project problems also helps students to develop the high demand soft skills that employers look for. Again, things like communication skills, analytical skills, quantitative skills, flexibility, adaptability, and problem solving, just to give a few examples. In this project-based format, all the subject matter is integrated. For example, the math is integrated with the reading and the writing and so on. And this kind of approach is ideal for STEM education. Also, because of the manner in which students must approach each of the projects being put forth in the curriculum, once again with the research and the testing and the group give and take, just to provide a few examples, this also allows for much deeper exploration of problems than traditional teaching methods might allow. Now, the projects presented in each unit are also designed so that if you have several groups working on the same project, what you should see are various variations in the prototypes and the solutions being presented. Now, this can be because of creativity, or it could be because of differences in the research or the approaches taken by each group. But in any case, students get to see firsthand that problems can have many different answers, and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, prototyping, testing, evaluation, and redesign phases of each solution. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. The team approach, as stated before, helps promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach, meaning that you can just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And once again, everything you need to conduct the program, with the exception of the programming software, as I've mentioned, is included inside of each box. Access to the free curriculum document download is included with the purchase of each set, once again, in any quantity that you purchase, whether you purchase 1 or you purchase 10 or what have you, you get access to that curriculum. Also included are all the building materials which students will use in the creation of each of their prototypes. Now, these materials are all from the unique Fisher-Technic building system, and among the components included in each set are 2 robotic controllers, such as you see on your screen now, and 2 power supplies. Of course, many of you may not be familiar with Fisher-Technic, so please allow me to provide you with just a little bit of background. Fisher-Technic is a flexible and innovative construction system. Now, unlike other popular construction sets, which are designed usually to simply stack, Fisher-Technic was created with more of an engineering mindset. The core building block in the Fisher-Technic system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. The system also includes a wide selection of very specific parts. For example, variations on gears and girders and sensors and so much more. And this allows technical builders to address equally specific design needs. Fisher-Technic was created back in the 1960s by German inventor Arthur Fisher, who's noted for countless innovations used in the construction and the automotive industries. Now, Mr. Fisher, at the time of his death in 2016, had amassed more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher-Technic, Mr. Fisher was the inventor of synchronized flash photography back in 1949, as well as being the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to anchor heavy objects to walls. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing, as well as providing consulting services related to automated processes. With all of that said, let's begin looking at each of the two individual sets. And we'll start off with the Studica Introduction to Mechatronics Program set, or for those of you who may like to use acronyms, you can refer to this as SIMP. The set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set, again, includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. The curriculum contains enough activity and material to fill approximately 45 academic hours. Now, as such, we recommend this program set for insertion into regular related class activities, for use as a short class unto itself, for after-school program use, or of course, for homeschool use. The curriculum created for this set is standards focused, again using the academic standards most widely recognized in US-based education today, and is designed for offering a project-based program. The set is designed for use in middle or high school classes, or again for addressing the same grade levels in a homeschool environment. The set contains a collection of over 700 Fisher Technic building components, and this includes everything from gears, wheels, axles, blocks, sensors, and much more, as well as, again, 2 robotic controllers and 2 power supplies. Only the required robotic control software, which we will discuss later on, is not included, but again, it is very affordable and it's available separately. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. There are also activities included to address the following topic areas that come up during the course of the curriculum. And this includes sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop and closed loop programming, working with digital branching, analog sensors such as the photocell LDR, working with analog branching, and more analog sensors as well, the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, let's first look at what is covered in the second set. And this is the Studica Teaching Applications of Mechatronics Program set, which is also known as STAMP if we want to refer to the acronym. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set comes with access to a free downloadable 400-plus page curriculum document entitled Mechatronic Applications, again by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. Essentially, 4 times the amount of academic hours is covered by the previous set. As such, this set can be seen more as a more expansive version of the material touched on in the previous set, and is designed specifically for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, every week for a full academic year. Again, this set is designed for offering students a standards-focused, project-based learning experience and is designed for use in middle school, high school, or again, for addressing similar grade levels in a homeschool setting. The materials in this set consist of a selection of over 1,200 Fisher Technic building components. And once again, this will include a wide array of gears, blocks, sensors, axles, and much more, as well as, again, 2 robotic controllers and 2 power supplies. Also, again, software is required for this set and is sold separately. Now, there are twice as many project units included in the Studica Teaching Application and Mechatronics Program set as with the set that we discussed previously, and they include units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, and this is followed by project-specific units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize. And these include sections on the following: sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and robotic controllers, open loop programming, sensors such as the digital switch and the digital phototransistor, closed loop programming, digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and also a section on working with data. Now that we've had a look at how each of these sets differs and the specific subject matter covered by each set, let's now look at exactly how the curriculum itself is structured. Now, both versions of the curriculum share the same format when it comes to the structure of each project unit, and as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. And what we mean by that is that each unit is designed to clearly spell out everything being addressed, and again, to provide tutorials and other information as the various topics arise. Now, this was done specifically to enable teachers from all types of backgrounds, including those teachers who come from a non-science or non-technology focused background. This was designed to enable them to quickly become comfortable with delivering the material simply by reviewing each section before they presented it in class. So essentially, if you do this, you don't have to take a special training session. You don't have to do a lot of back work on this. Of course, you're going to want to review the material before you present it. And again, there are going to be sections where we're going to have tutorial sections with working with the Fisher Technic system and what have you. I'd say if you review those sections, if you review each unit before you present it, and of course the material for that specific day before you get into it, you should be perfectly fine. Each unit presented in the curriculum for each of these sets will include the following sections: an introduction, the purpose of the project, the concepts being addressed, an outline, the standards, assessment rubrics, the essential question, a student scenario, the daily plan, vocabulary, and resources. Now we're going to take a look at each of these sections a little bit closer. And we're going to start off with the first thing you're going to see in each unit, which is the introductory section and the purpose of the project. Now, of course, just as you would likely gather from that name, this is the section that provides a brief description of the topic that will be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to the students why they're learning this material and why it's important for them to know. The next section that you'll encounter focuses on the main concepts to be addressed in this unit. And these can be thought of as the broad ideas that will be explored in the unit and the core information that students should take from this project that will be essential for them to understand and utilize not only today, but also to draw upon as they move forward in STEM fields of study, and if they choose to pursue it further in STEM-related careers. Following this, we encounter the outline. In this section, we drill down more specifically to what will be addressed in the unit. Now, as the example shown on the screen right now is taken from the unit that addresses aspects of programming, you will see that we also will touch upon areas such as the methods for writing programs, whether that might be flow charts or word problems or what have you, addressing program characteristics, things like is it open loop or closed loop, working with branching, for example, digital, analog, and subprograms, and so on. The next section you'll find in each unit focuses on the specific academic standards which will be addressed in the unit. As you can see, this includes the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include both rubrics for the specific project being covered, along with general rubrics for literacy tasks. Next up is the essential question, and this can be thought of as the big picture question that will be focused on in each of the smaller individual activities, and of course all the aspects of the larger project which students will be asked to complete in this section. The student scenario is where the specifics of the project to be addressed are finally spelled out. This is presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved with the creation of some sort of device or machine or mechanism. Now, as I mentioned before, students don't do this alone. They're going to be asked to work together in small teams to craft their answer to this challenge. Now, solving this problem will require each team of students to design a unique and original answer, which once again will usually be in the form of a working prototype, along with whatever programming may be required. Now, just to provide an example, if you look closely at the student scenario that I'm showing on the screen right now, you will see that the project in this unit has each group of students take on the role of a design team, which is employed by a firm that manufactures garage door openers. Now, in this particular case, students are being required to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are all spelled out, such as, for example, in this case, the use of limit switches, meeting certain safety codes that require a method for sensing that anything is in the way of a closing door, and also the incorporation of an automatic light. Now, again, each team of students will be tasked with creating both a unique and an original prototype, and in this case, that's the garage door opening system, as well as the programming needed to control the specific prototype. Now, as they move through the challenges being put forth in this scenario, each student team will be required to document the entire process in both a design notebook and a digital engineering journal. And in this case, they have to notate all the research, all the trial and error experimentation. They're being asked to keep copies of all design sketches and any revisions they make, and so on and so forth. And at the end of each of these project units, each team of students, again, will be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype, and again, if there's programming, their programming in action, much as they would be required to do so for an actual employer or client in the real world. The next section that we come upon is the daily plan. And this is the section that spells out clearly, again, both for students and teachers, what's going to be expected of students, how the teacher will conduct that day's classroom activities, and what specific subject matter is going to be covered. Now, if you look at this, some days you'll see may involve discussions, other days may involve research, and others will focus on the building of small projects that help to provide the building blocks that students will draw on to complete their larger projects as described in the student scenario. Now, in short, you could think of the daily plan as a roadmap designed to keep everyone on the same path. You will see too that along the way, as different aspects are addressed in each day's activities, such as, again, what is required in the design notebook, or how to use the control software, or working with the controller, or with flowcharts, or what have you. But as each of these things comes up, there are links to sections which will provide further instructions and information on each of these areas. At the completion of each unit, after the last day of the daily plan, is a section containing vocabulary, and these are important words and terminology introduced during the project unit, as well as a selection of useful resource materials. Now, these resources can contain a mix of different types of material, and this can be anything from carefully vetted websites and video links to PDF documents, PowerPoints, and much more. Now, besides the project units, each of the curriculum documents also includes a special tutorial section, which I talked about earlier, designed to educate both students and teachers on how to use the Fisher Technic building system. Now, this includes information on how the various parts fit together, using the pin and groove assembly method, identifying the different types of parts, from the various types of girders and blocks used to the different types of axles, rivets, gears, and much more. And students also get to build a very basic sample model just to help familiarize them with the building system before they move on to the projects in each unit. And again, as I mentioned before, this would be a nice thing for the teacher if you wanted to build some familiarity with it. Just look over this section, learn about the parts, learn how they fit together, and build that simple sample model. So once again, you understand the system. And as we're learning about maintaining proper documentation, and that being one of the areas that we really like to stress in the course of the curriculum, there's also a section which details just what defines each type of documentation listed on the screen now and what is required for each of these. And as the process of conducting these types of more open project-based class activities might be new to many teachers, there's also a section that discusses specifically project-based STEM education and its benefits. Now, as that completes our overview of these two sets, let me very quickly review the contents and the purpose of each set, but this time with pricing. First, we have the Studica Introduction to Mechatronics Program set, which is designed as a standards-focused, project-based introduction to the core concepts of mechatronics. Once again, it includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the building materials inside this set, will provide teachers with enough academic material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer a shorter class on this material, or who wish to use it for after-school programs, or of course for homeschool use. The teaching material is designed for use again in middle schools or high school environments, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. The physical materials included in this setting include a selection of over 700 components, again, a collection of blocks, gears, sensors, and much more, all taken from the Fisher Technic building system, along with 2 robotic control units and power supplies. These materials will once again be used to construct the mechanical prototypes addressed in each project unit of the curriculum. Software is again required, and we'll talk about that in just a minute, but otherwise everything else you need is in this set. Again, each set is designed for use by a team of 4 students at a time, with pricing starting at just $699 for a single set. And yes, discount classroom pricing for groups of 20 students and up is available by quote upon request. Next is the Studica Teaching Application of Mechatronics Program set. Once again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, which is based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, again written by noted expert Tom White. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity and material to fill approximately 180 academic hours. Again, this set is designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes per day for 5 days a week, or the equivalent, to this subject for a full academic year. Once again, the set is designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components from the Fisher Technic building system, and again, this includes blocks, girders, gears, sensors, axles, and a whole lot more, as well as, again, 2 robotic control units and 2 power supplies. Again, the required software is sold separately. Also, again, each set is designed for use by teams of 4 students at a time, with pricing for a single set starting at just $799 each. And again, discount classroom pricing for 20 students or more is available by quote upon request. Now, as I've mentioned that the software is required, and I've also seen there's a question already in the queue about software, let me address that as well. The software in question is the Fisher Technic RoboPro programming software, which is graphic programming software. And what we mean by graphic programming software, if you basically look at the example shown on the packaging and on the disc for the RoboPro software, it's basically using a flowchart style design made up of various icons where they're linked together. So the students arrange the program with the different icons to create the programming for each of these models that they're going to create. And this is ideal for teaching fundamentals of programming to users of all levels. And it basically teaches you the core concepts that are used in all sorts of programming, not just in graphic programming. But once again, this is graphic programming. Pricing for a single user license is only $36 each, and unlimited single site school licenses, meaning that you can have unlimited users at a single site or a building with this license. That means whether you have one computer, 100 computers, 200, however many you had, if you had 1,000, as long as they're in a single building, a single site, you can buy the site license, and the cost is only $120 per site license. And I also want to make known that these are not subscription prices. They're not annual licenses. They're not annual fees. These are non-expiring licenses that you have access to as long as you have access to the software disk which comes with each of these, and as long as you're able to install them on a compatible Windows-based desktop or a laptop computer using either Windows version 7, 8, or 10. As updates to the software are available, they can be downloaded free of charge to registered users from the manufacturer's website, once again, as they become available. So at that point, we can open it up for any questions. As I mentioned, I did talk about what the programming is. It's, once again, it's RoboPro programming software that's used specifically, graphic programming software, flowchart style design. I believe you can plug in other types of programming languages into the controllers that are used. The TX controller, we don't unfortunately supply instructions for how you would go about that, but I know it's been done. Anyone have any other questions? Who are the kits and curriculum being used for students that are working from home? Little confused on how that's worded, but basically, if students want to work from, or how are the kits and curriculum being used for students that are working from home? Well, basically, if you're working from home, I'm assuming we're talking about homeschooling students. Then obviously the students would, whoever is conducting the class in the home area, whether it be a teacher or whether it be a parent, you would use the curriculum document. You would share the curriculum document as well with the students. To give them, an idea as far as the roadmap for how things are going along. But basically, as long as you're using that, as long as they have access to the materials, they could do that. If you were instead referring to these materials being in a school and a student trying to access them from home, obviously no, that we're not set up for that. These are materials that the student does need to have access to and needs to be hands-on with. It isn't really set up for entirely remote use where, the whole idea of being able to build these things and do all the trial and error depends on them having access to all the materials in a physical way. But that leads me to another thing too, just to specify, if you're considering these for classes of students, when I mentioned that each set is used by up to 4 students at a time, we're talking about, like, for example, if you have a class of 20 students and it's 4 students per set, obviously, yes, you can get 5 sets for that class. The one thing I like to point out, though, is if you wanted to use these sets, if you want to have multiple classes going through these programs, that each specific class is going to need their own group of sets. The reason for that being is that the nature of the types of projects that students are going to be building with these sets, sometimes they're building very simple projects that they can build in a class period or 2 and take apart and move on to the next set or the next project. But in a lot of cases, what the students are going to be building, especially when they're building like that garage door system I was mentioning before, I think there's a project where they have to build an elevator or what have you, an elevator system. These are going to be things that obviously they're going to be in the process of building them over several class periods, sometimes a couple weeks. So again, each group of students need their own dedicated group of sets to use. Let's see, I have another question. Is there any certification exam that is related to this program for my students at the end of a Mechatronics semester course? Unfortunately, no, there is not a certification exam, no. Any other questions? I'll leave it open for just a second here or two. Okay, well, I see that I think we've addressed everything here. So of course, if you do have anything else that comes up, again, the question and answer window or the chat window, you can just go ahead and type in if you do. But in the meantime, taking the next step. So if you'd like to request a quote, excuse me, if you would like to speak with your dedicated educational representative, you can call us. Our number toll free in the US is Studica, and that's 888-561-7521. You can email us at info@studica, studica.com. If you do have any specific questions for me about anything that I presented today, anything I didn't present today, for example, I mentioned that, we work with the Fisher Technic system. We do offer other Fisher Technic products, Fisher Technic curriculum-based products, Fisher Technic robotics products, simulation products, and what have you. If you have any questions about any of those, want any more information on those, you can also write me directly. My email address is lance.zurek, that's lance.zurek @studica.com, once again. So on that note, I don't see any other questions coming up. We have addressed all those. So I would like to thank you all very much for taking the time to attend. We look forward to hearing from you soon.